Atkins Civil 3D video series, Road 6A, Corridor Assemblies. This video illustrates A. Default road assembly settings, B. Create assembly, C. Attach road sub-assemblies to one side, D. View and modify sub-assembly parameters, and E. Mirror assembly. An assembly is a Civil 3D object that consists of several sub-assemblies that define the road cross-section at specific locations. Half-width assemblies are used to define the corridors which contain intersections. When making a new assembly, it is best to copy an existing assembly, change the parameters, and add or remove sub-assemblies. It is also best to use predefined sub-assemblies included in the Tools palette that have numerous variable parameters. Set the object layer defaults for road assemblies. Tool space settings, right-click drawing name, edit drawing settings, object layers tab, assembly, Civil 3D corridor assembly, sub-assembly, Civil 3D corridor assembly. OK. Set the current layer to C3D corridor assembly. Set the assembly defaults. Tool space settings, right-click assembly, edit feature settings, default styles, assembly style Atkins, code style set style Atkins, default name format, urban curved full width, expand assembly type undivided crown road. OK. Load the Civil Imperial Sub-Assemblies Tools palette, Home ribbon, Palettes panel, Tool palette icon, the lower left. Create full-width urban road assembly, Home ribbon, Create design panel, Assembly icon, Create assembly. Name, urban curved full width, assembly type, undivided crown road, style, Atkins, code set style Atkins, assembly layer, C3D corridor assembly. OK. Pick location for the assembly. CO enter to start the copy command. Pick the previously entered text object, enter. Place below the assembly, escape, double click the object. Change the name to urban, curved, full width. Enter. Pick the name. In Properties palette, change the height to 5.0. Escape to stop command. Enter to start the move command. Pick the name and move below the assembly marker. Attach the road sub-assemblies on the left side of the centerline assembly marker. In Tools palette, select the Lanes tab. Select the lane outside superlayer varying width. Ensure the side is left. Pick the assembly marker. In the Curbs tab, pick Urban Curb Gutter General. Ensure the side is left. Pick the outside top of pavement marker where the edge of gutter is to be attached. Select Urban Sidewalk. Side is left. Pick the outside top of curb marker where the sidewalk is to be attached. Pick the Daylight tab. Daylight maximum width. Pick the sidewalk marker. Sub-assembly. OK. View the definitions, parameters, and other characteristics of a sub-assembly. In Tools palette, right-click a sub-assembly. Select Help. A model of the sub-assembly is displayed with a description of the various parameters. Attachment information, input parameters, target parameters that can be used for the alignment and the elevation inputs for other Civil 3D objects, output parameters, behavior, layout mode operation, point, link, and shape codes, along with a coding diagram. When finished, close the help page. The thickness of the pavement and base sections for a roadway are dependent upon the structural supporting characteristics of the subgrade soils and upon the design traffic loading. These are beyond the scope of this video. For this video, the road sections for the primary road consist of 4 inches of asphalt concrete pavement, which is to be constructed in 2 lifts, 16 inches of aggregate base, constructed in 2 lifts, and approximately 2 feet of undercut. The side roads and UAFS drive consist of 3 inches of asphalt concrete, constructed in 1 lift, 12 inches of aggregate base, constructed in 2 lifts, and approximately 1 foot of undercut. Modify the names and depths of the various layers in the left road lane subassembly for the primary road. Pick a subassembly object. In Properties palette, the Design tab, Parameters section, crown point on the inside, yes. Lane slope -2%. Lane width, change the width to 14 feet. Presently leave the width specification as match higher pavement layer, and also leave the inside and outside extended widths as default 0.00. Change the pave name, pave 1 name, AC Surf. Pave 2, AC Base. Pave 3, aggregate base. Pave 4, aggregate sub-base. Pave 5, undercut upper. Pave 6, undercut lower. The name of all layers 7 through 10 should be none, or left as default. Set the pave depth values. Pave 1, 0.17, enter. Pave 2, 0.17, enter. Pave 3, 0.67, enter. Pave 4, 0.67, enter. Pave 5, 1.0, enter. Pave 6, 1.0, enter. And the depth of layers 7 through 10 is 0. Okay. The curb subassembly default parameters are for a 6-inch curb with an 18-inch wide gutter and are left as is, except for the curb subbase section, which is generally constructed concurrently with a pave 3 aggregate base. As such, the right bottom marker of the curb subbase section must be coincident with the left bottom marker of the lane pave 3 aggregate base section. The curb subbase depth must equal the sum of the lane pave 1, pave 2, and pave 3 depths are 0.17 plus 0.17 plus 0.67, which equals 1.01. Pick the curb subassembly. In Properties palette, Design tab, Parameters section, change the subbase depth 1.01, enter. Escape. Modify the outside width of the base and undercut layers, pave 4, 5, and 6, in the lane subassembly. Road bases and road fill cannot be constructed in lift with vertical edges. The inside lane edges are vertical, but the outside lane edge of the lower base and fill layers extend outward beyond the edge of the upper layer. Pick an object in the lane subassembly. Property palette width specification for pave 4, 5, and 6 should be inside, outside offset. Pave 4 should extend 1 foot beyond the curb subbase, which has a width of 3 feet. Pave 4 outside extended width 4. Pave 5 outside extended width is 1. Pave 6 outside extended width is 1.5. Enter. Escape. Modify the sidewalk subassembly. Pick an object in the subassembly. In the parameters, inside boulevard width, which is the distance between the back of curb and the front edge of the sidewalk, 6 feet. Enter. Sidewalk width is 5 feet. Outside boulevard width is 0. Slope 2%. Depth 0.33 feet. Escape. Modify the daylight subassembly parameters. Pick an object in the subassembly. In Properties palette, cut slope 4.0 to 1, fill slope 4.0 to 1, maximum width 30, enter. Rounding option none. Place line materials, all links, material for each area, topsoil, 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 material thickness for each location, 0.33, 0.33, 0.33, enter, escape. Mirror the assembly to create the right side sub-assemblies. Use crossing window to select all the left side sub-assemblies. In the context sensitive ribbon, modify section, select the mirror icon, select the assembly marker. The right side sub-assemblies are created. Escape. Change the name of each sub-assembly. Pick a sub-assembly. In Properties palette, change name to Lane Left. Escape. Pick another sub-assembly. Change name, Lane Right. Enter. Escape. Pick the curb sub-assembly. Change name, Curb Left. Escape. Pick the other curb assembly. Change name, Curb Right. Pick a sidewalk sub-assembly. Change name, Sidewalk Left. Enter. Escape. Pick the other sidewalk assembly. Change name, Sidewalk Right. Enter. Escape. Pick the daylight sub-assembly. Change name, Daylight Left. Enter. Escape. Pick the other daylight assembly. Change name, Daylight Right. Enter. Escape. This video is a part of the Civil 3D video series created by Gerald Atkins of Atkins Engineering. Visit www.atkengr.com for instruction manuals, tutorial drawings, template drawings, and Civil 3D videos.